Good morning to another video of mine. In today's video, we will be talking about asthma and its genetic predisposition. We will be talking about its pathogenesis, which involves its causes, its consequences, and what we can do to remedy the situation or the specific treatment for asthma. Asthma basically is a genetic disorder which is increased if there is basically a family history of asthma in the parents. So what happens in asthma is that due to a the genetic mutation, there is increased release of inflammatory markers such as interleukin 4, interleukin 5, and interleukin 13. These all are involved in inflammation. Now there is also involvement of T helper lymphocytes Th2, which also releases these inflammatory markers and thus produces inflammation. Now we will talk about the environmental triggers. The environmental triggers include allergens, and the most common one is pollen, which is during the spring season. Now, what happens is that one person who is basically has asthma, when an allergen comes into contact with him, he releases IgE antibody, and this IgE antibody produces a type 1 hypersensitivity response, which is characterized by flushing and extreme release of histamine as well as acetylcholine release. Now, this is also accompanied by infections such as viral infections and in people who smoke, the irritant such as tobacco smoke, which contains nicotine itself, is an irritant to the lungs and to the bronchi. Now, if we talk in detail about the allergen sensitization, we talk about how the exposure to allergens basically produces these allergen-specific IgE antibodies, and these antibodies are produced by B cells, or also which are also known as the plasma cells in the human body. So we've talked before about how xenophils are produced during an allergen response, and how T lymphocytes recruit histamine, leukotrienes, and prostaglandins. Prostaglandins are basically the molecules which help to produce inflammation in the body. Now, what happens as a result of this inflammation is that the smooth muscles contract, and as the smooth muscles in the lungs or in the bronchi contract, naturally there is air resistance, and the air isn't able to get out from the human body, and thus there is difficulty in respiration and expiration. Now, over time, this entire process develops, and there is continuous fibrosis as well as the smooth muscle hypertrophy. This entire process is known as chronic remodeling, and during this process, there is goblet cell hyperplasia, which includes increased excessive release of mucin. Now we will be talking about the nervous system pathways. Within the airways, there are substances such as neuropeptides, such as substance P and neurokinin A. They generally basically respond to brain stimulus. However, in this case, they respond and contribute for the bronchoconstriction of the airway. I've already talked to you about how acetylcholine, which is itself a parasympathetic drug, is released into the body and further causes bronchoconstriction. Now, all these changes which occur are irreversible in the human body, and they trigger asthma. However, the viral infections and factors such as cold air and stress, and especially in winters, these all factors make a person more susceptible to such infections. Now, another reason why people are infected during winters is because the mucus layer is dried up during the winters, and the bacteria can easily thrive within winters. Now, what is the treatment, which is the final stage of our video I will be discussing is that the treatment to all this is that we use bronchodilators, which are beta 2 agonists, or we can use corticosteroids during acute flare-up of attacks. If a person has an extremely severe attack, he is admitted into the emergency and given 100% oxygen using nebulization. Thank you. I hope you had a better overview of the topic of asthma. I look forward to meeting you in the next video. Thank you.